So what is the assignment problem? The assignment problem arises when it is required to assign the job to most suitable person in such a manner that the total cost is minimum or total time required is minimum or efficiency or job is assigned to most efficient person. That is, a number of jobs are required to be performed and a number of persons are available to perform these jobs. Each person can perform each job, but we have to assign the job to most suitable person on one to one basis in such a manner that total cost for performing the job should be minimum. That is, the cost for performing the job by different persons may be different. So on this basis we can say that job should be assigned most suitable person, that total cost is minimum, or in terms of efficiency the job is assigned to most efficient person so that the job can be completed within that time. Instead of cost we can consider time, we can consider job efficiency or profit, etc. Originally assignment problem is used for minimizing the cost or minimizing the time, but it can also be used to maximize the profit or maximize the efficiency. For example, you all have seen the cricket games. In cricket team, there are 11 players involved, and these player can bat at any position. That is number 1 to number 11, that they can perform at any number. But their performance is would be best at certain specific position. For example, Sachin Tendulkar and Viren Sehwag performed very well as opener. Rahul Dravid performed very well as third place. MS Dhoni performed well at fourth place, and so on. So their performance was better than any other positions at the defined position. That is, if Rahul Dravid played as opener or as fourth position, then he out and smaller runs as compared to third position. So we can say that batting order is set in such a manner that maximum runs can be conceded. That means player should be placed at the place where he can concede maximum number of runs. So it such type of problem that a person can perform a job more efficiently is called as assignment problem. The assignment problem can be considered as a special case of transportation problem where all the rim requirements are one. That means availability at each origin is one, as well as the demand or requirement at each destination is also one, so that we can represent the assignment problem as a transportation problem using this type of transportation table. Here you can see four persons are available, A, B, C, and D, and jobs that should be performed are 1, 2, 3, and 4. That is four persons and four jobs. And here some quantities are mentioned. You can consider these as a cost of assignment. That is job 1 can be assigned to person A and its cost will be 6 unit. And here you can see the availability at for each person is 1 and requirement for each job is 1. That means all the rim requirements are 1. So we can say assignment is a special case of transportation problem. And transportation problem, and since availability and demand all are equal and one, we can represent the same table in this form where availability and demands are removed, and this table is called as assignment matrix. That is person, job, and cost of performing the job. As transportation problem was a special case of linear programming problem and assignment problem is a special case of transportation problem, we can directly say that assignment problem is a special case of linear programming problem. And an assignment problem can be written as a linear programming problem as follows. Objective function can be written as minimum of z equals to summation I goes 1 to m summation j goes 1 to m cij xij. Here you can see in example that number of persons and number of jobs are equal. So variation of I and j will be also same. I goes 1 to m and j goes 1 to m also. So so we can say that minimum of z, as we are minimizing the cost, z will be minimum. Minimum of z will be equals to summation I goes 1 to m, summation j goes 1 to m, cij xij. Now constraint can be written as summation I goes 1 to m xij is equals to 1 for all j goes 1 to m. As you can see that the total availability for each person is 1. That means sum of all the xij's will be equals to 1 over all I. Similarly, for if we sum column wise, then we will get the constraint summation j goes 1 to m xij equals to 1 for all I goes 1 to m. Here two restrictions are followed. One is called as non-negativity restriction, that is xij greater than equals to 0. And other restriction is xij takes only two values 0 and 1 for all values of I and j. If xij equals to 0, we said that job is not assigned to a particular person, and if xij is equals to 1, then we said that j's job is assigned to ith person. So we can solve the transport assignment problem same as linear programming problem, that is by using simplex method, as well as by using different methods defined for transportation problem. But that will become more complicated, and an easiest method for solving the assignment problem is called as Hungarian algorithm. This method was defined by D. Koning, which was a Hungarian mathematician. That's why it is called as Hungarian algorithm. It has certain examples. Sorry, it has some steps. First step is check whether the problem is balanced. Balanced means the number of jobs and number of persons must be equal. If problem is not balanced, a dummy row or column which is smaller in count is added with all cost coefficients 0. If number of persons will be smaller, then we include a person or more persons as per requirement to make balance, and all the cost coefficients in the row of persons will be 0. Similarly, if number of job is smaller than number of persons, then number of columns will be included or number of jobs will be included, and all the coefficients in the job will be 0. Second step is to check whether the problem is minimization type. As the original method is for minimization, so it is required to check whether the problem is minimization type or problem is for maximization type. So if the problem is minimization type, then there is no problem. But if it is a maximization type, that is profit is available or efficiency is available, then there are two methods to convert the problem into the minimization type. The first method is multiply all the profits in assignment table by -1. That means each and every quantity in assignment table should be multiplied by -1. Or other method is find the maximum profit and subtract it from all the other profits. That means if we consider this table as a maximization problem, then either we can multiply each and every element by minus 1, that is here it will minus become minus 6, minus 1, minus 9, minus 3, and so on. Or in other method we have to find maximum of these quantities, which you can see is 12. So we can subtract each quantity from 12. That is, here we place 12 minus 6, which is 6. Here we place 12 minus 1, that will become 11. Here 12 minus 9, which would become 3. Here 12 minus 3, which would become 3. Similarly 11, 7, 10, 4, and so on up to last unit. And at the place of 12, it will become 0. So by using this method, we can also convert the given problem into the minimization type. Now it should be noted that these checks, that is step 1 and step 2, performed in same order as mentioned. If we change the order of these steps, then the results would be misleading. Now third step said that find the minimum element in first row and subtract each element of the row from it. Sorry, find minimum element in first row and subtract it from each element of the row, and repeat the process for all the rows. Next step said find the smallest element in the first column and subtract it from each element of the column, and repeat the process for all the columns. It would be explained with the example later. Now step 5 is draw minimum possible horizontal and vertical lines to cover all the zeros. All lines may be horizontal, all lines may be vertical, or there may be a mixture of vertical and horizontal lines. However, there is a condition that we have to draw minimum possible lines. For minimum possible lines, we started from the row or columns having maximum number of zeros, and draw line according to that row and or that column that have maximum number of zeros, and repeat the process till all zeros are not covered, or you can say not connected. If the number of lines comes out to be equals to number of rows or number of columns, that is order of the assignment matrix, then we move to step 8, otherwise we go to step 6. So if number of lines are smaller than the number of rows or number of columns or number of, sorry, or order of assignment matrix, then we have to find the minimum element among the elements not covered by line, and subtract this element from all the elements not covered by the line, and add the element at the intersection of two lines, that is horizontal and intersection of horizontal and vertical lines. Then in next step we repeat step 5 and step 6 until the number of minimum possible lines covering all the zeros become not equal to the order of assignment matrix. Next step said make the assignments. For making the assignments, we consider the assignment matrix having zeros only, and all the other quantities which are positive quantities are removed from the assignment matrix. Then we encircle the zero which is alone in the row or the column. That is, find the row or column having single zero, then encircle this zero and cross other zeros in corresponding column or rows. If single zero is obtained in row, then other zeros in the columns are removed, or if the zeros are of single zero is obtained in the column, then zeros of corresponding row are crossed off. This is called as assignment. The process is repeated till all the jobs are not assigned. That is, till all the assignments are not made. So example will sorry steps will be become more clear when we consider the following example. The example said that ABC company is engaged in manufacturing five brands of packed snacks, it having five manufacturing setups, each capable of manufacturing any of its brand. That is, we have five brands B1, B2, B3, B4, and B5, and five setups S1, S2, S3, S4, and S5. The cost of making a brand on these setups are given in the following table. That is, cost of making brand B1 by setup S1 is rupees 4. Similarly, cost of making brand B1 by using setup S2 is 6. Similarly, so other costs are available. We have total 25 costs. Now, according to Hungarian algorithm, we have to check in step 1 the problem is balanced. So here we can see that we have 5 rows and 5 columns. That is 5 brands and 5 setups. That is number of rows is equals to number of columns. So our problem is balanced. The second step is to check whether the problem is minimization type or not. So as per the question, the cost is mentioned. So cost is to be minimized. So our problem is minimization type. So first two steps are, or you can say first two checks are performed, that problem is balanced and problem is of minimization type. Now in next step, we find the minimum element of first row and subtract it from the row. So here you can see in first row there are 5 elements 4, 6, 7, 5 and 11. Among these 5 elements minimum is 4. Now this 4 is subtracted from each element of the row. So row will become 4 minus 4, 6 minus 4, 7 minus 4, 5 minus 4 and 11 minus 4. That is, we would get 0, 2, 3, 1 and 7. Then next step said repeat the process for all the rows. In second row, the minimum element is 3. Now from each element we subtract 3. That is, it would become 4, then 0, 3, 6 and 2. In next row, here it is 4 is minimum. This 4 is subtracted from each and every element. That is, this is obtained. Then in next row, 7 is minimum. 7 is subtracted and this is obtained. In last row, 5 is minimum. We would obtain 2, 0, 4, 3 and 6. So after subtracting minimum element of the row from each element of the row, this table is obtained. Now next step is performed on this table, not on the original one. Next step said find the minimum element of the column and subtract it from each element of the column. So in first column, minimum element is 0. In second column, minimum element is 0. In third column, minimum element is 0. In fourth column, minimum element is 1. And in fifth column, minimum element is 1. That is this one. Now this 0 is subtracted from each element of the column, so there will be no change. Similarly, in second column, there will be no change, and in third column, there will be no change. In fourth column, 1 is subtracted from each of the element in the column. So we would get 0, 5 to 1, 1, 2. Similarly, in fifth column, minimum element is 1.
सर C25 सर
Just,
1 की जगह 2
just
होगा
so here these are the minimums. So here we would get 5, 1, 1, 2 and 4, 0, sorry 6, 0, 4, 2 and 5. That is this matrix. So now we draw the minimum possible lines by covering all the zeros. So here we can see in first row there are two zeros, in second row there are two zeros, third row 1 0, fourth row 1 0, and fifth row 1 0. Similarly, in first column we have 1 0, second column we have two zeros, third column we have two zeros, fourth column we have 1 0, and fifth column we have 1 0. So maximum number of zeros in a row or in a column are 2. So we draw first line by connecting two zeros row wise or column wise. So we consider first B1, that is first line is drawn here. Now since these two zeros are covered, we will not consider these zeros in drawing next line. We may connect or we may not connect as per the requirement. Similarly, next two zeros in B2, this line is drawn. Then again in same column two zeros occur, that is S3. So we connect these two zeros first or cover with these two zeros. So this third line is drawn. Now only 1 0 is remaining, that is in B5. So we can draw line horizontally or vertically, 0 will be covered. I have drawn it horizontally. So you can see that all the zeros are covered by the lines. There is no zero remaining which is not at any of the line. And here we can see that four lines are drawn, whereas the order of the matrix is 5. So the number of lines are smaller than the order of assignment matrix, which is 5 cross 5. So we move to step 5. Sorry, we move to step 6. That is find the minimum element not at the line. So the minimum element not at the line, the elements not at the line or not covered by the lines are 4, 1, 2, 5 and 1, 1, 4, 2. These 8 elements are not covered by the lines, and among these minimum is 1. We can take any of these as minimum. There are 3, 1, 1, 2 and 3. So minimum will be 1, whether you can consider this, you consider this or you consider this. Now this one is subtracted from all the elements which are not covered by the lines. That means this element covered by line, this is covered by line, this is covered by line. Similarly, these 8 elements are not covered by the line, so 1 is subtracted from these elements. Here we would get 3, here we would get 1, it will be 0, it will be 4, it will become 0, it will become 0, it will become 3 and it will become 1. That is this type of table is obtained. And similarly we add this one at the intersection of the two lines. Here you can see two lines are intersecting, so one is added here, it will become 4. Similarly one is added here and one is added here, that is at 3 points one is add and other elements remain same as these one. That is the table would become these like this. Now we again consider this table and again draw the lines. Now here we can see the maximum number of zeros occur in B3. So first we draw the line according to the row of B3, that is cover 3 zeros. Now in B1 there occur 2 zeros. So we cover these 2 zeros in this manner. Similarly 2 zeros occur in B2 and so in this manner we would obtain 5 lines. That means there are 5 lines and order of matrix is also 5. So it is our optimum assignment matrix and we will move to next step, that is step 8, and make the assignment. For making
Assignment.
assignment we consider this table where only zeros are represented. Here you can see S1 and S2 in B1 have 0. Sorry, S1 and S4 have 0. So here S1 and S4 have 0. All the other positive quantities are removed. Now we make assignment. Here in first column, we can see there here is only one zero. So we encircle this zero, and corresponding all the other zeros in the row of this zero will be crossed off. So this zero occurs in the row of B1. So there is only one zero. It is crossed off. Then in second column there are three zeros. In third column there are two zeros. In fourth column there are two zero. Whereas in fifth column there is only one zero. So we encircle this zero and crossed off the zero in corresponding row, that is this zero is crossed off. Now in each column we can see there are two zeros, but we can move further through row. In first two row assignments are made. Now in third row there are three zeros, fourth row there are two zeros, and fifth row there is one zero. So we encircle this zero, that is this zero is encircled, and corresponding zero in the column is crossed off. Now in each row, remaining each row and each column there are two zero. We can arbitrarily select one of these four. I have selected this one, and the zeros corresponding to column and row of this zero are crossed off. That is, these two are crossed off, then it will be selected automatically. Now we can write assignment as brand B1 is manufactured from setup S1, B2 is from S2, B3 is from S3, B4 is from S4, and B5 is from S5. And cost of assignment from assignment table it is obtained 4, 5, 4, 9, and 5. That is minimum cost is rupees 27. But since here I have selected this one arbitrarily, I can also select this one as arbitrarily. That is, assignment can be made in this manner. This one, then this one. These three will be same. Now here instead of this zero, I have selected this zero. And other two are crossed, then this one is selected. That means again brand B1 is from setup S1, brand B2 is from setup S5, but B3 is changed. In first solution it was from S3, now B3 is manufactured from setup S4, and B4 is manufactured from setup S3. B5 will remain same as first one, that is B5 is manufactured from S2. And again we if we write in the same type, that is cost from original assignment matrix, then it will also give a total of 27, which is equal to previous one. So we can say that if same row and columns contain more than one zeros, then we can also obtain an alternative solution having same minimum value. That is, it is a case of alternative optima in assignment problem. These are the reference considered.